Cryptography is like a secret code system for the digital age. It's about protecting information and communications through the use of codes. This way, only the people who are supposed to see and read the information can do so. Imagine sending a postcard with your biggest secret written on it. Anyone could read it. Cryptography makes sure your secrets stay secret. Cryptography isn't just about keeping things private though, it's also about making sure that the information you receive hasn't been tampered with. Think about getting an email from your bank. You need to know for sure that it really came from your bank and not someone pretending to be them. That's where digital signatures come in. Just like a handwritten signature on a document, a digital signature verifies the sender's identity and ensures the message hasn't been altered in transit. Imagine you're sending an important document to a business partner. How can they be sure it was really you who sent it and that no one changed anything in the document? That's where a digital signature comes in handy. A digital signature is like a fingerprint that's unique to both you and the document. It uses something called a hash function to create this fingerprint. This function takes your message, however long it may be, and transforms it into a short code. This code acts like a fingerprint for your message. Now, if even a single letter in your document changes, the hash function will generate a completely different fingerprint. This makes it nearly impossible for someone to alter the document without being detected. One of the most popular algorithms used for digital signatures is the Digital Signature Algorithm, or DSA. It was proposed by the National Institute of Standards and Technology, NIST, back in 1991 and has been widely used ever since. DSA is based on some pretty complex math involving something called modular exponentiation and discrete logarithms. But don't worry, you don't need to be a math whiz to understand how it works. The basic idea is that DSA uses a combination of a public key and a private key. Your private key is like your secret password that only you know. You use it to sign your digital documents. The public key, on the other hand, is like your public email address that you can share with anyone. People can use your public key to verify that a document was indeed signed with your private key. Section 4. Breaking down DSA, a step-by-step guide. Let's break down the DSA process into simple steps. First, you need to generate your public and private key pair. This involves some math, but luckily, computers are really good at math. To sign a document, you use your private key along with the document itself as input to the DSA algorithm. The algorithm then spits out a digital signature. To verify the signature, someone would use your public key, the document, and the digital signature. If the signature is valid, it means the document was indeed signed with your private key and hasn't been tampered with. If even a single bit of the document has been changed, the verification process will fail. Section 5. DSA in action, real-world examples. DSA is used in a wide range of applications to ensure data integrity and authenticity. For instance, in email security, DSA is used in email encryption to verify the sender's identity and make sure the email hasn't been tampered with. In software distribution, software companies use DSA to digitally sign their software packages. This way, users can verify that the software they're downloading is legitimate and hasn't been infected with malware. And in financial transactions, DSA is also used in online banking and other financial transactions to secure communication and prevent fraud. These are just a few examples, and DSA is constantly being adopted in new and innovative ways as technology evolves. Section 6. Wrapping up DSA's significance. In a world that's becoming increasingly digital, it's more important than ever to ensure that our information is secure and trustworthy. DSA plays a critical role in achieving that goal. It provides a robust and widely used mechanism for digital signatures, guaranteeing the authenticity and integrity of our digital interactions. So, the next time you see a digitally signed message or document, you'll have a better understanding of the clever cryptography that's working behind the scenes to keep our digital world a little bit safer.